today we're going to be looking at molar gas volume. Alright? Before we start with the idea of molar gas volume, I want to talk to you about the concept of volume by itself. Okay. Now, volume is obviously a unit of measurement that talks about a measurement of space. Okay. So sometimes we have liquid measurements like milliliters. Sometimes we have distance measurements like centimeters or meters. But volume tends to refer to the amount of space that is taken up, which means it is a three-dimensional measurement. Okay? It's a three-dimensional measurement, and it includes the length, the height, and the breadth of an object. Okay? Or the depth of an object. Three measurements are involved. Okay? Having said that, I want us to start off by realizing that when we talk about volume, we're talking about a cubed unit. A unit that is raised to the power of 3. Make sense? Okay. So let me just take a cube very quickly. If this is my cube, and I'm talking about a measurement in terms of this cube, if I were dealing with centimeters, okay, if I had 1 centimeter by 1 centimeter, and this measurement was 1 centimeter, I would end up with the volume being equal to the length times the breadth times the height, which would be 1 times 1 times 1, which would give me 1 centimeter cubed. Do you agree? But if I use another unit, a different unit, for instance, like millimeters, I know that how many millimeters do I have in a centimeter? 10. So I have 10 millimeters, 10 millimeters, and 10 millimeters for the same block. Do you agree? The same block. So when I do my volume calculation, it's again going to be length times breadth times height, but this time I'm going to have 10 by 10 by 10, which will then give me how much? 1,000 millimeters cubed. Now the reason why I'm showing you this is because the conversion, when we talk about volume, the conversions don't make sense. Alright? Because we know that in every 1 centimeter, we have 10 millimeters. But in my next sentence, I'm going to say to you that 1 centimeter cubed is equal to 1,000 millimeters cubed. So now it feels like I'm changing the conversion, but I'm not. I'm actually just taking into account that because we're dealing with 3 dimensions, it's going to be the 10 times the 10 times the 10. Do you see that? And I want you to see that because when we deal with the conversion in terms of volume, some of the conversions will look funny and you'll be like, why is it not 10? Why is it 1,000? And this is the reason why. Because in volume, we are dealing with 3 sides or 3 measurements multiplied together. Are we okay with that? Yes. Now, let's talk about the fact that when we deal with volume, we can link volume to moles as well. Okay? So I want you to imagine inside of this block, I have 1 mole of a gas. Okay? 1 mole of a gas inside that block. What do you know about 1 mole of a gas, grandparents? What do you know about 1 mole of any substance? What information do you know about it? Yes?
6 times 10 to the power 22.
6.02 times 10 to the power of 23 particles inside of 1 mole. Okay? So now I have 0.02 times 10 to the 23 particles of gas. I know that about that particular sample of gas. But there's something else I know about the sample of gas which is really cool. Because 1 mole of any gas always occupies the same amount of space. It always has the same volume, which is actually something that we're not very happy about. We're not very happy about the fact that any gas will occupy the same space if you have 1 mole of it. But it's because of a couple of different factors. So if I have 1 mole of any gas, it is always going to occupy a volume of 22,4 decimeters cubed. Okay? So 1 mole of any gas always occupies a space. So 1 mole of any gas will always occupy a space of 22,4 decimeters cubed, regardless of what the size of the molecules are. Okay? The reason for this is because there are a lot of other variables, like if the molecule size changes, then the attractive forces between the particles shift, so they take up more space or they take up less space according to their sizes. Okay? However, if we have 1 mole of any gas, it's going to occupy a space of 22,4 decimeters cubed. There are some T's and C's. What are T's and C's? Terms and conditions. Alright? There are some very, very important terms and conditions. And the terms and conditions here are that they must be at something called STP. Alright? It must be at something called STP. What is STP? Anybody know? Anybody? Just randomly. STP refers to something called standard temperature and pressure. So STP refers to standard temperature and pressure. Standard temperature and pressure are values that you get on your data sheet, okay? And those values on the data sheet should be 0 degrees Celsius or 101.3 kilopascals. That's the temperature one, and that's the pressure one. Okay? So at STP, 1 mole of any gas will occupy a space of 22,4 decimeters cubed. There should be one more thing here that makes you feel a little bit uncomfortable. What is it? It's the unit. What is this decimeters that I speak of? Right? It's not a unit that you're completely familiar with, is it? No. So decimeters, bless you my angel, decimeters is a unit that falls within the distance measurement. Okay? Right? And what we get is, we get millimeters, then centimeters. I'm going to write it at the bottom here, and I'll go back and just talk to you about it. We get millimeters, we get centimeters, yes? Then we get decimeters. And then we get meters. Yes? So can you see, it's the 10, it's the 10, and then it's a 10. So there are 10 decimeters in a meter, and there are 10 centimeters in a decimeter. You see that? Okay. So that's kind of like the range of measurements. Okay. I'm going to pause here.